So now I want to look at shell basics part 1. So what is the shell? What do we mean by shell? So shell is actually a program that takes command from your keyboard. So anything that take command from your keyboard and gives them out to the operating system, that is even if it's your Windows or your Linux operating system. So instead of you operating in, for example, your desktop in your Windows, you are using an alternative method of running through a shell command, and you are using codes using your keyboard to type in those codes to navigate around the shell. Okay, so shell is a program that takes command from the keyboard and gives it to the operating system to work on. All right, so that's what shell is. Then what is terminal? So terminal is just the window of shell. Like for example, this Ubuntu now, so this is actually a terminal, so it's like a software. Okay, so it's a software that opens a window that let us able to navigate on our shell, okay, on our operating system. So this one is just this Ubuntu is just for Linux, just like your Git bash or like your Windows command prompts. So those stuffs are terminals. All right, so now what is shell prompts? So shell prompts is just your what's that stuff that I usually show you. Yeah, so your username and the name of your system, like the name you name your laptop. Okay, so your username, name of your system, and this $sign. So all this thing you are seeing here in our home screen, in this our home position, is actually what we call the shell prompts. All right, so the shell prompt is located in the terminal window, which this is the terminal window, which it contains our username. This is my username here, Lexis code, and the name of the machine followed by the $sign. All right, so that's it about that. Okay, now what are the dots and the dot directories? Well, as we should already know by now that a single dot is just telling us we are in a specific directory. Like for example, right now we are in our home directory. Okay, and these are the folders that are inside our home directory. So if I, for example, do cd dots, it won't take me anywhere because the single dot is taking me in my working directory, which is this my home directory. Remember, this home directory, let's confirm. So you can see. So if I say cd dot, I'll still be in my home directory. I won't go anywhere. So you can see. So that single dot is just allowing you to remain in your working directory. So that's the most of the time we usually ignore it. We just rather do our normal cd without putting the dots. Okay. But once you now put something like double dots, then that double dot has a difference, which means it's going to take you one step up to the parent directory of the directory you are working on. For example, if I do cd dot dot, remember we're in the home directory inside the Lexis code. So that means if I do cd dot dot, it should take me to the parent of this Lexis code, which is this home. So if I click enter now, you can see that's the home here. You can confirm that by using pwd. So that's what it does. All right, so that's just it. And let me just go back again to the home. Now if I can go to the grandparents, like right now I'm in the Lexis code directory. Okay, and if I do cd dot dot, it will take me the parents of the Lexis code, which is home. Okay, I know this home too has its own parents, which is the root directory. So that's like the grandparents of Lexis code. So that means if I do something like the cd dot dot / dot dot, so to take me first to the home, then it will take me to the parent directory of the home also, which is the root directory. You can see we're in our root directory. You can see the change in the arrow sign. / is what is showing here, which shows that I'm in my root directory. So if I do ls, you can see these are the options of my normal root directory. Okay, so that's just how to play around this. And next, we want to look at cd space dash. So what that stuff does, that it just take you to the previous working directory. So before we got to this root directory, what was our previous working directory? If you notice here, our previous working directory was the home directory here. So when our home directory before we got to this place, that means I can easily go back to my home directory. Although the easier way to do it at this point is just for me to do cd enter. So that one is faster, you get. But there are some other cases that you won't use cd enter, because cd is only to the home directory. So if I do cd for cd dash, is take me to the previous working directory, which eventually it's our home directory. Okay, so let me just look for another scenario that won't be in our home directory. Let me look for another example to explain this. Let me use another directory entirely. So let me use this dev.plus. So now I'm inside my dev.plus now. Okay, now if I want to go to the previous working directory, remember my previous working directory was this home directory here before I entered inside this dev.plus. Okay, that means if I want to go to the previous working directory, I can say cd dash, or since cd is, one thing about what we've been doing about coding, we always use the shorter way to make things faster for us. So instead of me doing cd dash, which will take me to my home directory, I already know cd will take me to my home directory without needing to put the dash. So let me start that example. Let me go back up. So now I'm in my home directory. Now if I ask now what is my previous directory before I got to use my home directory, my previous directory was dev.plus, right? So now I can go back to this previous directory without doing cd dev.plus again. So I can just do cd dash, and if I click enter, and it has taken me directly to the text. So this is a perfect example for it now. So that is what I'm trying to achieve. So I don't use that home directory, so because cd is already home directory, so I want to use that kind of directory so I can really understand the practical aspect of this cd dash and the advantage of it. Okay, so this is just a way of doing it, just going to your previous working directory fast, that kind of thing. Okay, I think that's it about that. Okay, so what's next? Let me check my notes. Okay, so what is the difference between soft link, which is also known as symbolic link, and add link? So what's the difference between soft link and add link? Now, just imagine in your Windows laptop now, whereby if you download the software, you notice those software usually have shortcuts, right? Like they have an app icon of shortcuts, and that shortcut, if you notice, they're usually in kilobytes, like 10 kilobytes, 20 kilobytes, but the main file you installed can be in gig, but the shortcut can be in just 20 kilobytes. So that shortcut is the soft link in a way. So it's just a way of directing, of a short way of us clicking it, then to look for a way to connect to the major file, then open it for us. All right. So whereas the add link is just like creating another copy of the original file. That's what add link is. Okay, so just like you have an original file, then you have a copy of that original file again elsewhere in the same laptop. Okay, so now let me differentiate the difference now. So this scenario now for the soft link now, which I use example of the shortcuts app icon we usually know of, that we usually put in our desktop screens. If for example I delete that shortcut from my desktop, as for from my home desktop, okay, if I delete that shortcut, it doesn't mean I've deleted the real file of that application. I can still go back to that file and open it even without using the shortcut. You understand? But now in the scenario of the add link, if I delete the original copy, the one I first installed of the application of the software, so if I delete the file, I can still access it. Like, it doesn't mean I've lost it. I can still access the whole file in the copied version, because I said I copied the original software. So it's just as if there's no real difference when it comes to add link. When it comes to soft link, there's a difference, because once, for example now a soft link now, if we have shortcuts and we have the original file, if I delete the original file, that shortcut is useless. Okay, that's a good example now. If I should delete the original file of an application I installed in my laptop, and the shortcut is still in my laptop, if I open the shortcut, it will take me anywhere. It will show me error message because the original file has been deleted. Okay, unless I delete the shortcuts and I can still access the original file without the shortcuts. You understand? But when it comes to the case of the add link, both files are actually like equal in a way. Okay, so they are equal. So there's something called the inode. So soft link has a different inode. Okay, that is like the shortcut. The shortcut has its own inode. different from the original file inode. But when it comes to add link has the same inode, exactly the same as the original file inode. Okay, by inode means index node. Okay, so what is inode? Inode, it contains all the file informations. So a specific file, it contains a file information except the file content, that is what is inside the file and the name of the file. Just see it like an example now, whereby you have a personal ID, you have a passport, but in that your passport, your name is not there. Okay, so something like that. Like imagine having a passport whereby your name is not there at all, but your age is there, where you come from is there, but your name is just there. Maybe they just give you a number, so your name is like a number, they call you by numbers, so something like that. So that is what inode is. So every file has an inode internally. Okay, so let me repeat again. If something has a different inode, so different inode shortcut has its own inode, different from the original file inode. Okay, but when it comes to add link, both of them has the same inode. The add link has the same inode as the original file link has the same inode. Okay, so that's just their differences. Lastly, what does LTS and RTFM mean? So LTS is just a short form in Linux, a Linux support system, which means long-term support. So LTS means long-term support. Why RTFM? It's just a funny meaning though. It means read the fucking manual. Okay, so I don't know the necessity of this. It's just for us to probably get fluent with some kind of terms, so that when you see your colleagues saying some certain terms, you'll be like, what is this one saying? So it's just like a slang or a short way in Linux. Okay, so that's just stuff. Now let's move to Linux wildcards. So wildcards are very handy when it comes to searching for particular file names from a heap of similar named files. So the purpose of this wildcard is just for us to be able to navigate and to search or to list or to remove certain files that may look alike and that may be too much. Okay, so they're too much and you can't be checking them one by one. So there's a quicker way for you to easily do it, to find something, or to find a particular file in a big list of files. Okay, so there are different techniques you can use. So that's where these wildcards come in. So I'm going to see more on these wildcards in this shell basics. Okay, so I'll just do some brief introduction of the wildcards using these first three wildcard commonly used option. That's the asterisk, the question mark, and the brackets. So in the next videos we'll do more examples as regards to wildcards. All right, so let's see this first three. So the first one, which is one of the most popular commonly used wildcards, is the asterisk. Now this means it will match any number of characters or a set of characters. It will match any number of characters or a set of characters. Now let me show you what we mean by that. Okay, I'm in my dev.plus and I created some random files. Okay, so I just created these files down before creating this video. So just assume we have several files. Okay, just put that in your mind, and they're like scattered in this way, and you want to uniquely find some specific format of file right up. Okay, instead of you looking at them, probably they can be actually more than this, you get. So instead of you just looking at them with your eyes like this, to be stressful to really find. So there are different short way of doing it in a way. All right, so now let's see the application of using the asterisk aspect. So one example we can use the asterisk aspect for example, if I want to list. So if I want to list any file name that starts with S and has any other name after it but end with N. Pay attention to what I said. I want to list all files that starts with S, small letter S. Remember, Linux is case sensitive. That starts with small letter S. And any name, the file can have any name in between this S and N. Doesn't matter. It can be SAN, can be SEN, can be SAEON. It should just be between S and N. So that asterisk will just take whatever words or whatever character that are in between it. Okay, so it will take words that start from S, small letter S, and end with small letter N. So let's list it and see for ourselves. You can see all of them start with S and end with N. Okay, and what is in between them doesn't really matter. I can say we have OA here, while here we have UN, we have UU here. So what is in between doesn't really matter. That's the work of this asterisk. So this asterisk doesn't care about any right top or format of the name. All this care about is just for you to list random things. That's what the asterisk does. Okay, but I put a boundary to it whereby it should be something that the word will start with letters, small letter S and small letter N. So just like I said, that Linus is case sensitive. So I can, if I use capital letter S and small letter N, show me for the aspect of capital letters. You can see now, you can see there's no small letter here also. So capital letter S and small letter N words that are in between in this format. Alright, so this is just like one of the examples of this. And I can choose to list all files to like this. So what this asterisk, this ls, just as if I do something like this ls. Okay, so something like this. But this time around, it lists every single file that is in within this dev.plus. So that asterisk lists every word. Remember, I didn't specify from beginning to end in this part. So that's why I list everything for me. They won't enter this new directory and this what is inside this new directory here. But if I just do normal ls only show me the directory that is within this dev.plus. You didn't tell me what is inside this new directory. So that's one of the difference about this stuff. Let's see if I can use another example. So I can still see something like SU asterisk. So if I say SU asterisk, what does this mean? It means I'm listing any file that their name starts with SU and end any way they want to end. Doesn't really matter to me. On that the words, the beginning of that file, I can remember the name starts with SU. That's just the only thing you can remember. So you want to find that file in a long list of files. So you just say SU, then you put that asterisk. So it only lists specifically this format you are asking for. You can see this is the only thing I'm asking for. So SU, everything starts with SU. Then the rest words doesn't really concern you. Your own is then to find the particular one you are actually looking for. So this is how to play around with asterisk. Okay, so there are different ways you can just choose to play around this stuff. So I just chose to use this basic example so you get the point about the whole concept of asterisk. So that's what asterisk does. So the next one, looking at question mark. So this means it will match a single character. Okay, so what we mean by that, for example now, I don't know, should I clear this? Let me leave it like this. Okay, let me take it one page up and I will scroll a bit like this. Okay, good. Okay, so we want to look at what do we want to look at again? Sorry. Okay, we want to look at the question mark aspect. So from what it says there, it means it will match a single character. That is if you put one question mark there. So what I mean by that is, for example, if I want to list, if I know that there's a file that I know that starts with S and ends with N, and there's only one word in between them, I want it to be strictly one word in between them. That means I will say S question mark N. That means whatever is in this question mark, it can be A, it can be B, it can be A to Z in between. It doesn't really concern me. So I just know that there are 3 words. The name of the file I'm looking for has only 3 letters inside. Rather, it has only 3 letters, and I know it starts with S and I know it ends with N. But I'm not sure the particular letter the stars in between. So that's why I chose to list everything in this way, so I can find the particular file I'm looking for. Okay, so you can see these are the only file that meets up with this condition that I gave here. So that's just what question mark does. If I do something like this now, S2 question mark, that means I'm saying there are 2 letters in between them. So the question mark is specifying the number of characters that are in between those regions. Okay, so this one will print out for me words that start with S and end with N, but has 2 characters or something inside. You can see you have you have UN. So you can see the difference between this one question mark. It only takes only 1 character in between S and N, while this one it takes 2 characters because of the 2 question mark. So that's just the difference between all of the aspect of question mark and the aspect of asterisk. So I believe this example is explanatory enough for you to get your concept of question mark. So lastly, let's look at the brackets. So this means it will match characters that are enclosed. It will match characters that are enclosed in square braces or square brackets. So let's just see what brackets own means. Let me do two examples as regards to this bracket. So for example, now if I do something like this, SLSONN. Now let me explain what this code means. Now I'm saying that I'm telling the shell to list for me all files that start with capital letter S. So all files that start with capital letter S and end with small letter n. Okay, but then in between S and N, it can have SON or SNN for me. And as you can see, we have ON inside the bracket. So one word we take inside, that is SON. Then the other N that is inside we take it, so that's SNN. So if I click list now, you can see it only lists the SON, which means I don't have SNN. That is why. Let me list all my files to be sure if I have anything like SNN. Capital letter S. I say all my capital letter, we don't have SNN, so we only have SON. So that's why there's only SON here. Okay. So that's just one example of it. So you know what? Let me just quickly create SNN. Okay, so let me do that stuff again. So you just see how it is really working. So you can see now it prints for me that SNN. So it will print the S, O, and the last N. Also, it will print the S, N, and the last N. So it depends if you have that files in your list. So you are just trying to bring them out to be able to show off the file you're actually looking for. So the brackets. So this is how the concept of the brackets works in wildcards. Okay. Let me do one more example. So for example, if I want to list something like should I use small letter like S? Okay, let me just capital letter. I think that's the example I used for. So ADN. So what do you think this will mean? Now what this means, just the same concept of this one. Okay, but this time around we use A to D. Instead of writing A, B, C, D inside there. So you can choose to write A, B, C, D inside there to still work the same way. But because of the stress of the length of writing A, B, C, D, we'll just use A dash D to represent A, B, C, D. Just do we go to our ON here. Okay. So the same format, it will just list any file that has SAN, SBN, SCN, SDN. So that's what that command means. You can see now SAN, SBN, SCN, SD. So that's what the brackets aspect does in the wildcards. So I believe this is very, very explanatory enough for you to get your concept about this. So you'll see more of using wildcards in the next lecture. I believe you understand this aspect very well. Thank you.